Hello everyone, let's go over Lecture 28, Designing Experiments. I'm your instructor, Ms. Laura Lowe. In Module 10, the first thing we talk about normal distribution. Then we show you according to our sample means distribution. Then we come out the central limit theorem. So today's lecture, the last lecture in Module 10, we will use the central limit theorem. Then we construct the confidence interval for our sample mean. Then at the end, we will see how should we choose the size for the random sample. And in today's lecture also, kind of appreciate our first friend. So you will see some emoji in there. Okay, so let's talk about the Lecture 28. So we will continue to look at the distribution of average of a large sample. To conclude what we learned from the past two lectures about the central limit theorem. So here is the summary. So remember this central limit theorem, we always have the sample size is large and we draw at random with replacement. Then regardless the distribution of the population, the probability distribution for the sample average will be roughly to normal distribution. So since they are roughly to the normal distribution, not only we know the population mean will almost equal to the sample average mean, and also the sample average standard deviation will equal to the population standard deviation divided by the sample size, take the square root. So how we got that conclusion, actually we can see, remember at the end of last lecture, we did three different sample size. We have 100, we have 400, and we have 900. And here you can see we have the 400 only and 900 only here. But with each sample size, we do the 10,000, we find 10,000 sample mean. Then we construct the empirical distribution. Then we find out, no matter it's 100 size or 400, 900, the distribution all close to the normal distribution. And you can see the center will be close to the population center. That will be the population mean. With the sample size is larger, the width of the bell will be narrower. And it happens we also calculate the standard deviation of the population compared to the standard deviation of the sample mean. Then we get the standard deviation for the sample mean very close to the population standard deviation divided by the square root of the sample size. Remember we use the 100, 400, and 900. From those information we get, what they can help us. So here we want you to see three different standard deviation. The first one, the population. Of course, this one we're still using the United Flights delayed information. So you can see this one is the population distribution. So the green triangle points to the population mean. Then we can calculate the population standard deviation is about 27 minutes. Then let's take only one random sample for the size 100. Then we will plot on the information like this. So you can see here, instead of seeing like the before, we have the 10,000 sample means. They got the same. They got almost like distribution as normal distribution. If we only get exactly one sample, then you see the distribution. They are far from normal distribution, but close to the original population distribution. Then we calculate their average. So of course, this average, we will just calculate everything, then we got the mean. Then we see they were close to the population mean. Of course, they are not exactly. So you can see here is the green is population mean. So then we have the other value is the blue one. That's the sample mean for this sample size. So then the standard deviation for the sample actually will be close to the estimation of the population standard deviation. And compared to earlier we get, so this one actually is just the random sample one time. The standard deviation will be close to the population standard deviation. But if we got the standard deviation of the sample average, so that means we got the 100 flights each time, but we do 10,000 times. Then we will find out actually the standard deviation of the sample average will close to the standard deviation from the population divided by square root of the sample size. Then, of course, when you try to calculate the mean, actually they should closer to the population mean. But we have the standard deviation equal to 2.7. So that came from your population standard deviation divided by square root of the size. From all the different standard deviation, actually they will help us to get the sample, or we can get one sample, then to estimate our population sample in a range. So this in a range, we back to talk about our confidence interval. If you remember the confidence interval, we first introduced that about our bootstrap. So that's the same thing, we try to estimate the population mean, but we only have one random sample. So then we use a bootstrap to simulate, or we say we resample the same sample size many times according to this random sample. Instead, we give them exactly one estimation value. We use the confidence interval to give the range for the population average. So for today's lecture, we applied the central limit theorem to estimate the population mean. We will apply the same thing for the confidence interval. Instead, give the one estimate for the population mean. We will give them an interval of our population mean. So what does that mean? Let's see our graphic of the distribution. So for example, this one is a distribution for our sample average. So we have the sample size n. So then, of course, this sample average, we have many sample average. So we got a distribution. So this will look like close to the normal distribution. And in the center will be the sample average and also the population average. So from this center, we can also find the standard deviation, because the standard deviation for the sample average will equal to the population standard deviation divided by the square root of the sample size. And do you remember in the previous lecture we talked about when we have a normal distribution, it's very important. Most of the data will be under 99% plus minus 3 standard deviation from the average. So that's using the 2 times standard deviation. So from the average, from the center of normal distribution, the plus 2 standard deviation and minus 2 standard deviation, this area will cover at least 95% of the data. So that's how we will construct our 95% confidence interval. So the key to the 95% confidence interval is after we got our distribution of our sample mean, we know the center will close to the population average. So then according to the population standard deviation, so then we can construct 2 standard deviation to the right and the left. And this will be 95% for the whole sample. So the standard deviation from the sample average will equal to the population standard deviation divided by the sample size, take the square root. Yeah, then you will ask, but how do we know the population standard deviation? because we are not trying to estimate the population average. So on the other hand, we don't know the population standard deviation either. So then we need to see again, in order to constructing the interval of the 95%. So the first thing you remember, you stand at the population average. You look 2 standard deviation to the right, to the left, then that's their interval. Okay, so your sample average actually should be in that range, 95%. And also the distance is symmetrical. So on the other hand, we know if we have a population average, they will be within 2 standard deviation to the sample average. So if you stand at the sample average, you look at 2 standard deviation on both sides, you will catch the population average, about 95%. We just look at this one first. Okay, so if that's still kind of a little confused for you, we just see here. So we talk about we get our sample average. Okay, so right, our center will close to the population average. However, they still have an interval for that. Because one thing is, we can get our sample average, but in order to see they are your population average, we are still kind of is the interval. Because remember, this sample average is maybe 10,000 sample average. Yeah, here, then we construct this distribution. So that's on the other hand, that means the 95% confidence interval, we note at least 95% sample average in this range, right? So it's in this range. So on the other hand, we also can say our population average will be in this range as well. Because remember, we are not getting 10,000 sample. We are only get 1 sample average. So this sample average, they may be here. So that's why, see how far they from the population average. So that's we say that's a relative distance. But no matter what, 95% confidence after we got our sample average, after we got our average from 1 sample, they will have within 2 standard deviation distance from the population average. So that's why here you will see. What we will do now is, after we got a sample average, so then we're using the sample size we know. Then we're using the standard deviation of the sample. So then we can construct the standard deviation of the sample average. So within 2 of that, 2 standard deviation, so this range will have 95% confidence covered for the population average. Let's see the example, so then we'll help you understand better. So we're back to our lecture. So here's lecture 28 demo. So again, we see our Alameda baby example. So this example, like we said before, they have almost 1,200 rows, and that's a sample. That's not population, it's just a sample set with almost 1,200 rows. So then let's get the bootstrap. Remember our bootstrap, right? So we will get this sample. So here, each time we can resample that. We're using the mom's age. Okay, so then you have your bootstrap each time. So then the bootstrap, we're using this sample data. We do 3,000 times. So that means we draw by random, but with replacement. Okay, so then we can get our bootstrap. So then from this 3,000 sample average, then we construct 95% confidence interval. So we find the 2.5 and 97.5. So that's why here from the bootstrap, we got the confidence interval for our population mean is in between here. Okay, so remember this one actually is before. Just try to remind your, refresh your memory. Remember before we used the baby weight table, then we apply the bootstrap to resample 3,000 times. Then using the confidence interval, we got the estimation for the population average in this range. So now for this lecture, we are using the center limit theorem. We are not only need to do 3,000 bootstrap resample, we just use one sample from here to get the population mean estimation. So I will continue in the next video.